Hello friends, we have already seen in the last video that what compiler design actually is, what compiler actually does. Okay, so we have seen that compiler specifically converts high level language or pure high level language into assembly code. Okay, but it is not something like compiler will do it immediately in a single go. It doesn't work like that. Okay, so we are having various steps inside compiler, and this high level language will go through all the various steps or all the various phases, and at the end of all these phases we will be getting something that is known as assembly code or the target code that is needed. Okay, so in this video we will be getting a overall idea. I will be giving you an overall idea of all the phases, that what the phases are all about, how it works, and in the next videos we will see them in detail as we proceed. Okay, so first of all let's get an overall idea what these phases are all about. First of all, we are having high level language. Now the first phase is lexical analysis. This high level language will go as input in lexical analysis, and what this phase will do is, from this high level language it will generate the stream of tokens. Now we know, right, what high level language is. High level language is nothing but any language in which the human beings are writing the code. Like it may be English language or any other language that is understandable by human. So from this human understandable language or high level language, we are having words, sentences, right? So among those words or sentences or the code that is written, lexical analysis will find out or identify the stream of tokens within that stream of tokens. To give you an idea, let me give you an example. If I have written integer like int I equal to 10, if I have written int I equal to 10, int will be a token, I will be a token, equal to will be a token, and again 10 will be a token. And if I am having semicolon at the end, then again semicolon will be a different token. So in this way, from our whole code, this stream of tokens will be identified with the help of this lexical analysis. Now the second phase is syntax analysis. So what syntax analysis is, it will take this stream of tokens as input, and with the help of this stream of tokens it will generate a tree, and that tree is known as parse tree. Okay, so syntax analysis will take the stream of tokens that is generated by lexical analysis, and then with the help of these tokens it will generate a tree called parse tree. The third phase is semantic analysis. It will take the parse tree as input that is generated by syntax tree, and then it will check whether this tree is semantically verified or not. It will check this parse tree semantically. So it will take this normal parse tree as input, and as a output it will give semantically verified parse tree. Okay, now this semantically verified parse tree will again go into intermediate code generation. What it will do is, it will generate 3 address code. Now it will actually not always be 3 address code. This 3 address code is one of the forms of intermediate code generation. Okay, it may vary also, it may be anything different also, but 3 address code is nowadays mostly used as intermediate code generation. It is mostly famous nowadays. Okay, so intermediate code generation will take the semantically verified parse tree, and it will generate 3 address code. Now what 3 address code is? It is called 3 address code, as the name itself indicates, because it will take 3 operands. 3 address code means what? It will be having 3 operands in it. In one step 3 operands will be there. For example, a equal to b plus c. If I am writing a equal to b plus c, then it is 3 address code, because a, b, c, 3 operands will be there. Okay, so that is 3 address code. Now after generating this intermediate code generation, after generating this intermediate code in the form of 3 address code optimization will be done. Like I have written 3 address code, right, but for example I have written 10 lines of 3 address code. So in this next phase, that is code optimization, it will look that is it possible to optimize that code, is it possible to optimize that 10 line of codes into 7 or 8 lines. If it is possible, then it will convert that code into a smaller version of it if possible, and if not, it will make it as it is. It will make it remain as it is. But if it is possible to shorten or to decrease the number of lines of code, this code optimization phase will decrease the lines of code. Now you just understand the idea, how it is, what it is done, how the phases are working, but how it will be done with the help of an example, I will help you in the later, I will show you in the later video, so don't worry about it for now. Okay, so for now just understand and have the clear idea, just an idea that what the things will be done in each phase. So code optimization, it will decrease, it will try to decrease the number of lines in the 3 address code that is generated. After we are getting an optimized code, then that optimized code will be given as input in this target code generation. This target code generation is the last phase. It will take that optimized code as an input, and as an output it will go finally give this assembly code. It will finally give this assembly code, and as we have seen in the previous video, this assembly code will be then given into the next phase. In after compiler we are having assembler, so this assembly code will go into the assembler. Okay, so we are not going into that now. For now you have to understand these phases of compiler, how this high level language is finally converted into this assembly code with the help of all these intermediate phases. So these phases are very important to understand. Now apart from these phases, symbol table manager and error handler, these two are will be connected with all the phases. Okay, these two things will be connected with all the phases of compiler design. It will be connected with all the phases. Right. Symbol table manager and error handler, these two are very important topics, these two are very important concepts of this compiler design. To give you an overview, symbol table manager is what you can consider it as a table that is used to store various important information regarding compiler, and error handler, as the name itself indicates, it is used to handle in case any error arises in any of these phases of compiler. Now in detail what symbol table manager and error handler is, we will be seeing these things also in detail in the next videos. Okay, so I hope you have got the overall idea of all these phases, what these phases are, what it will be doing. Now how it will be doing with an example we will be seeing in the next video. Okay, thank you so much.